Anyway, welcome everybody to our gathering tonight. My name is George Dado. I am president of the Chester County Bee Association, and we're hosting this really special gathering tonight. And first, I'd like to thank everyone for giving up a little bit of their personal time to join us to learn a little bit more about the Bee Research Lab and upcoming changes proposed to it. I'm going to tell a brief personal story about my interaction with the Bee Lab. I been a beekeeper for 15 years, and last year at one of my apiary sites, I opened up a hive in the spring, and it didn't look right. There was a whole lot of brood disease early in the spring. It was affecting open brood, and I wasn't sure what it was because about a third of the bees were being affected, and I couldn't quite put my finger on it. It sort of looked like sac brood virus, but I've never seen sac brood virus so disseminated. So I called up the state inspector in Delaware, Emily Wine, and she suggested that I reach out to the bee lab at Beltsville. I was like, wow, I've heard of this, but I've never had any interaction with it. Uh, so I got a name, Dr. Judy Chen. She had an email, and I sent her a very benign email, not saying I was present, not saying anything important, just I'm a beekeeper and I have a problem, and I heard you can help me. And within basically an hour, she responded back, introduced herself, told me that she could help, told me what I needed to do to send samples to the lab, told me that it was all on Beltsville to get it done, and basically walked me through it. And then I sent the samples. I paid for the shipping, and then she said, "Well, we have money to cover that." I said, "No, that's my contribution to this. I'm perfectly okay to cover the shipping for this." But she volunteered to reimburse the shipping. And then I hadn't heard from her. And then about 2 weeks later, I get an email back closing the loop saying, like, we did all the virology, and the only thing that we found in your hive was sac brood virus. And we've seen other cases of just disseminated sac brood virus, and we're really appreciative of you sending the samples and contributing to the science being done at USDA. And I really felt two things from that. I felt valued and important as a beekeeper that I was contributing, and I also was thoroughly impressed with the closing of the loop by her along the process. So again, two thumbs up from my standpoint to the Bee Lab and all the folk at the USDA and how they're supporting our bees and our beekeepers. So again, I'd like to thank Zac Lamas for coming on short notice and being our feature presenter tonight. And at this point, I'm going to turn the talk over to Carissa, who is one of the leaders of our women's bee group in the CCBA, to introduce Zac tonight. Again, thank you all for joining.
Thanks, George. And thanks, everyone. I know everyone is eager to hear Zac, so I will keep it brief. And I just wanted to introduce him just in case people don't know who this mysterious Zac Lamas is. Dr. Zac Lamas is a researcher at the USDA ARSB Research Lab in Beltsville, Maryland, where he studies how varroa mites drive viral transmissions in honeybee colonies. When commercial beekeepers began reporting severe colony losses earlier this year, Dr. Lamas led a team of USDA ARS researchers who worked urgently to analyze samples from around the country and determine potential causes. Dr. Lamas recently became a visiting researcher at the University of Maryland in Baltimore County, where he plans to continue the critical work he started at Beltsville. He's joining us today to talk about the potential fate of this world-renowned research facility. So we are very happy he's here, and Dr. Lamas, for coming on, and I will hand it over to you.
Thank you so much for that introduction, Carissa. And actually, the person that I need to, or the group that I need to give a thank you to is this Chester County group. This has been phenomenal. We were able to organize this quickly, and we are both a really important but yet a small industry, so we can get together pretty quickly, which is great.
These are Zac's views and don't necessarily reflect or not reflect the views of Chester County Beekeepers Association of Pennsylvania or its members.
This was difficult to put together, putting something together very quickly. But you should see a picture of a building with the words Beltsville Agricultural Research Center. This is both a very professional talk for me and a personal talk for me. I had always wanted to go to grad school and didn't know how to. And when I say I didn't know how to, I grew up in a broken home, and neither of my parents at that time, as I was growing up, had gone to college. So I had no real idea of what it meant to go to college. It was a very foreign idea to me. And when I graduated, all I wanted to do was farm. So that's what I did. And I graduated at the worst time in the history to be a college graduate, 2008 in May. And there were just no jobs. And I jumped into farming. And I took what I call a 10-year gap year. About 10 years later, I had wanted to go into research and I wanted to pursue a scientific pursuit. I just didn't have an idea how to. And at some point, I just made this decision that I was going to stop. I was either going to scale up my business, make hires, lease a warehouse, go from about 400 colonies to a couple thousand, or I was going to go back to school. And obviously, I chose the back to school route. And I felt very out of place in academia. This place was very much the opposite. It's a highly collaborative research center. It's extremely supportive. It's a safe space. And I know I wouldn't have a career if it wasn't for BARC. BARC stands for the Beltsville Agricultural Research Center. And it really is much more than a bee lab. And so for the rest of this talk, I want to introduce you to BARC, briefly some of the other labs, and then show you some of the people in our lab. If someone's not shown, it's not because I'm omitting them. It's just to try to stay within a time restraint. And then I'm going to talk about this year's losses and a loss event that we responded to 2 years ago. And the reason that I'm going to do that, show you those loss events and how, as a collaborative unit, we can respond as quickly as we can. I know my name got blasted on the internet a bit as Zac Lamas going to do this, but the reality is we have a high-functioning, super nimble, very motivated working team that responds to losses on behalf of beekeepers. And I want to show you what we were able to do with our team, and then what the plans are for the reorganization. As George introduced, this is not a political talk. Professionally, though, I have professionally, I want to see STEM, so science, technology, engineering, and math, expand. And BARC is part of that. So this is BARC right here. This is an aerial view. Originally, it was a 475-acre farm. And in 1910, that farm was purchased for the pursuit of doing research on behalf of stakeholders. It has grown quite a bit. It is now a 6,500-acre research center. We're the largest agricultural research center in the United States with 17 different labs. Now, if you were to go up to the BARC official website, you get kind of your typical boilerplate, almost non-emotional government web page, and you can surf around on it. What I'm going to do is show you some of the people behind BARC and some of the landscape of BARC, because it's much more than that. But I'll stay here for a second. Beltsville Agricultural Research Center is wholly devoted to serving stakeholders, and in this case, farmers and the American public. And we're a mission-driven research center. That's very different than your universities or a nonprofit. Our purpose is to serve our stakeholders. So our job titles and what we can do is make seem restrictive on paper. It's actually pretty broad. And this goes from everything to doing diagnostic services. Many of you are familiar with that coming out of our bee lab. But actually at BARC, it also involves APHIS labs that are screening for pathogens that we don't know are here yet, or pests that we're not sure if they're here yet, coming in from ports in other countries. We have an imaging lab that will, for free as a core facility, do complex imaging services for other labs on campus. In fact, the first author paper I published is that imaging lab was a big part of it, where we showed how Varroa are not how that they're actually moving material back and forth between bees when they feed upon them. We do poultry science here, poultry disease. We work on invasives like the brown margulated stink bug. And the thing that often gets missed is we're resource rich. Essentially, everything I want is at my fingertips, both in terms of personnel to assist me, or in the rich resources we need to do honeybee research. So this is a picture just outside of one of my research yards on BARC, and it's another facility, and they look for plant health at this particular facility. And when we say we're going to reorganize BARC, this is just kind of one of the little landscapes that actually means. Now we have yards dotted all around these sites. We have other people doing corn and row crop research on the side. When I pull up into my yards, we're surrounded by other farmers that are doing either pest studies or cover crop studies. I have a yard right off over here on the right that's tucked in there. And we really benefit by being surrounded by other researchers, and most importantly for the bee lab, being on a contiguous green space. If you ask any university researcher, they're going to tell you all of the difficulties that they have to deal with trying to get their research done. Often their barn or their apiaries are off campus, so they have difficulties driving to them, or students have to navigate parking on campus and then getting into a vehicle and getting over to a research site. I literally walk out my back door. So we do a lot of research really quickly. And part of that is due to the rich forage that we have around us in this rich green space. I'm going to talk about it a little bit later, but for honeybee research, we really are in this Goldilocks zone. And it's one of the testaments I give for always having a bee research lab in Maryland, specifically in Beltsville. So we don't have beekeepers around us, and we actually like that. I mean, we have some hobbyists around us, some small sideliners. We have a small commercial a few towns over, but we're not inundated with commercial beekeepers around us. And that's great because we want to study what's impacting the commercial beekeeper without constantly being exposed to that pathogen or that pesticide. So we like the fact that we can easily travel to a beekeeper, collect samples, and then come back and do research. Not every site has that opportunity. We're also doing it on a space doesn't have heavy ag pressure. So if we were doing this in the middle of Kansas, we're gonna have a lot of ag pressure and we're not gonna have diverse forage. We have the opposite here in Maryland. So we're able to carry out a lot of research simply from not having heavy ag exposure and not having heavy beekeeper exposure. The next thing is we have a long period in which we have access to our honeybee colonies to get material. So for example, I can get brood usually middle of February, depending on the year, sometimes middle of March. And I have access to that brood all the way through February or until November. That's a long research season, but we still get a winter. In fact, we get a winter where our colonies go broodless and they can die if they have a pre-existing condition with winter stress. That's phenomenal because when we're running field trials, we're representative of a lot of the country. And we also get these brood breaks and the colonies can shed viruses. So we really like doing research here. Now, there's nothing wrong with doing research in Florida. And like the University of Florida has a beautiful research system. It's just not always translatable to a lot of other parts of the country. So we like that. The next thing is we actually have quite a bit of contact with DC. We're not that far away. We're down the road. They're with traffic 45 minutes. That means when we're doing tours, we potentially have a lot of contact with staffers. Now, we don't have enough, in my opinion. And my opinion is one of the assets of BARC being here is the staffers of policymakers can come through for tours. We have way too much of our country not in contact with the farmers actually growing the food that sustains us 3 times a day. And if you watch Netflix as much as I do, 5 or 6 times a day, because there's a lot of snacking that goes on, right? Whereas we have that opportunity to give them a soundbite of what's impacting beekeepers. Someone comes through our lab for a tour, we're presenting them about Varroa, we're talking about pesticides. We want to make sure that we have that, even though it's a snapshot, to be able to say, this is what's impacting my stakeholders, this is what we're researching. With this year being a very special year, we're now telling them this is a $600 million problem. One of my worries is with the reorganization and moving out of this area is we lose that contact. And for an industry, we need to find a way to maintain it or increase it. We're a very important industry. Culturally, we're also important, and we support a lot of other crops. So I think I just snapped this in my car just because it was pretty. But imagine 6,000 acres of this and a lot of it being wooded. So when they say reorganization, there's no plan as of right now of what this reorganization would ultimately look like in terms of the permanence of this federal facility, whether it would get developed by other federal agencies or if it'll eventually be sold off for developers. We know the communities around here, especially like bicyclists coming up from DC or down from Baltimore, love this area because they can traverse our roads. Now, we've gotten some bad rep for dilapidated buildings in the DC area. This is one of them. This used to be a research lab. It was closed down. I don't know the specific reason why this one was closed down. When they get shuttered, they go into disrepair pretty quickly. If you can imagine any building being shut up for a while. So our site is filled with buildings like this. They're more expensive to repair and bring them up to code than they are just to leave them there. They're more expensive to break them down. We kind of love them because we just put all of our apiaries around them. They're great mode sites, and we have these research yards dotted all around. The reason I'm showing these pictures, though, this is a barn that fell out of use well before I was there, and I've been there almost a decade. Is the reason I'm showing these pictures is, one, there's some raw beauty in them, especially as kind of nature is reclaiming a building. But this is what happens when we start to pull funds from either state or federal research. Things that have been built, I heard this used to be for goat research right here. Things that used to be functioning on behalf of service to Americans essentially start to decay. And it's much harder to repair that than it is to keep something going. We have all these houses that are actually dotted around the property too. I have another research yard just down here on the left. In fact, this is a view going to that research yard. I said that I just walk out my back door and do research. This is me smiling the other day just because I felt so beautiful doing research on this beautiful site. I snapped a quick picture of this morning. I literally showed up at work, said hi to everyone, grabbed these frame holders, went out and collected brood from 12 different colonies in an experiment, and then brought them right back inside. And the whole thing took me under an hour and a half. It took me 5 minutes to drive to the yard. We're able to do a lot of work because, again, we're resource rich. And I'm speaking only on behalf of the bee lab right now. We have our poultry and our dairy, plant pathogens, our imaging. They're all resource rich as well in this one site. So they're able to get a lot of work done as well. We do a lot of research at the USDA, and because we have the space available for it and so many different scientists, we'll actually do quite a bit of varied research that isn't always practical at a smaller facility. I'm showing this just because they're pretty cells. I'm going to be honest there. That's the sole reason of showing that. But Jay studies is investigating antivirals. The ultimate goal is to develop an antiviral product. It won't be a silver bullet to help beekeepers, but it will be a stopgap measure to help bees. And I had these collapsing colonies last summer. And I said, you know, if we kind of shake them together, we can turn them into mini nukes, and you can do your antivirals with high replication and super low cost if you want. The reason I'm sharing this is we tried it. We had the space to do it. We weren't interrupted, by like if we were at a university by a football game or having tons of people around. We quickly set up the trial. It didn't work. That was okay. Failure is a big part of science. But we essentially wrapped up all our materials and got going. This is Jay Evans. He was both on my committee and my boss, and represents really one of the steadfast scientists at BARC. The reason I'm showing this picture here is Jay is the most mission-driven person that I know, both Judy and Jay. And what do I mean by mission-driven? That means that he's not out to get a big paper in his name. He's not interested in necessarily pursuing science that doesn't benefit a stakeholder. If someone calls him up, just as George described it early on with Judy, and needs help, we find a way to give that person help. And Jay exemplifies that more than any other person I know. It doesn't stop with stakeholders. He brings in tons of people on a volunteer status. These are students that get firsthand experience, learning what it means to become a scientist. We have a lot of interactions with stakeholders, and we simply make ourselves accessible for that. Jay pioneers that. And it's in the culture of BARC, not just in the B lab, but the other labs. We develop, I'm just going to speak for we, so I can cover a bunch of people, methods so that we can do research a lot quicker. So these are P cups that Jay developed, and it's a super low cost way for him to screen antivirals. It's one of the examples of like a kind of a simple thing that they'll pioneer at BARC and then run hundreds and hundreds of trials. Our unit, so collectively the whole B lab, look at emerging threats as a really big issue. We helped bring new miticides to market. That was a really big deal for us, and we're really proud of that work. The next picture, I'm only showing this because these mites are in a saline solution. It kind of looks like they're getting waterboarded a little, which if some of you really hate Varroa, that's a fun picture, but I'm just kind of showing it here. But ultimately what we do at BARC is we ensure food security. Whether you're working in poultry, which is really busy right now, or dairy, or in our case, bees or plant pathogens, we have a mission to make sure that we are helping secure that food goes from farm to table. And fundamentally, industry and the federal government and universities understand that a lot of research won't be funded in the public sector. And a lot of that is basic research or sometimes expensive diagnostic services. For example, with APHIS, they screen for pathogens and pests that aren't here yet. That's an expensive service that the federal government wholly undertakes. We do this because we're mission driven to ensure food security and service to stakeholders. We have approximately 180 scientists on campus. I already talked about the Goldilocks location in terms of the winter and access to DC and not being too close to stakeholders. We have access to farmers without being near them. That's a really important part of us being able to carry out the work that we do. But the thing that really gets missed in all this conversation is how important our integral working groups are. I don't know everyone in this who showed up to listen to this talk today, what you do for work. I know if you are someone that has to work with others, you have some people you prefer with, some you don't. Some you trust, some you don't. You have some people that you know if you walk over and ask them a question, not only will they give you an answer, they'll help you get to a solution very quickly. We have a culture of that latter part at both the Bee Research Lab and at BARC. And one reason that our work moves ahead so quickly is that when I have an issue, I don't have to wait for an answer. I actually just walk over to someone's office and ask them a question. I'm going to give an example of that later on. Whereas in a lot of different research centers, when they're quite small and you only have one or two scientists at the center, if you have a speed bump, you have to send a colleague an email or someone you don't know an email asking a question. You got to wait for them to respond. I literally go from my workbench to someone's office, ask, get a reagent or answer on a protocol I need, and I go right back to my work that same day. And we have a culture of just opening up information to our working groups. And I'll talk about a couple different examples of that later. On top of that, we have really healthy working relationships with stakeholders. I snapped this as a picture. This is in California. Some of you might recognize some of the beekeepers there. Judy Chen is right there in the center. And we were sampling all day for beekeepers. And then Judy was set that we were going to have dinner with a few of them because we're going to miss them on the trip otherwise, knowing how important those stakeholder relationships and interactions are. I think I had this a little out of order because this is us sampling at Almonds during that day. If it looks cold there, it actually is. On top of this, we also have a lot of visiting researchers that come. So this is Eugene Ryabov. He helped develop the NanoLuke, which is this modified virus that allows us to do the antiviral screening super quickly. Him, Jay, and Judy pioneered it. Not a visiting scientist down below, but a really great example of this scientist. So Shane had the ability to make queens, but just kind of wanted to up the game so she could run an experiment really cleanly. And we quickly did it this summer. So when I have a question, I just walk down the hall. This is actually really important to me. We live, okay, so in a lot of different places, people don't necessarily share information, and it holds back research, it holds back innovation. We just share where we are. It's in the culture of BARC. So last winter, I mean, and this isn't a unique thing to me. Everyone wants to know, is your comb infectious? And I had all these dead outs, and I was like, oh, I really want to know if this comb is infectious. But I didn't know how to extract the comb to detect the viruses on the comb. It's not the most intuitive process. It's not the easiest thing. Long story short, over the course of 3 weeks, I did a bunch of trial and error and ultimately came up with a very quick, very easy, low-cost way to detect pathogens on combs, specifically viruses, although we can also do nosema and EFB through an RNA extraction as well. And the melting curve up there is just showing that it worked. But what I did was I knew a bunch of people had already done this. So instead of me just jumping into it, I walked over and I asked Michelle, and then I asked Judy, and I asked Dawn. I kept asking them little questions like, hey, when you tried to extract comb before, knowing that at some point in their work history they had, what didn't work? And if this is how you have to ask people to really get ahead. Don't ask them what they did or what worked. Ask them what didn't work. And people will get frustrated and just start sharing information. So within 3 weeks, came up with a super quick way to extract pathogens from comb. And the reason I'm sharing this and why it's so important is I did this not this year, last year, just because I had extra time and a curiosity. This is the culture of where we work. I get a text message in the morning after I got back from California this year, and Jay goes, we need to know if there's pathogens on those combs. And I think my response was essentially, okay, I'll get on it. Because I had done this the previous year and worked out the methods, I knew I could immediately just start processing some of the comb we had collected for pathogens this year. That is the benefit of having so many collaborative, interwoven expertise in a single place. And the final thing I really want to cap on is the reason like we keep approaching this work is we're mission driven. We want to ensure food security. We want to ensure that farmers are making money, and that when someone goes to a grocery store, what they want's on the shelf. The best way to exemplify that is to talk about this year's bee losses. And I'm going to try not to go over on the time, and I'll just hope that George or Carissa will give me like a 10-minute heads up if I'm going too long. This year, as everyone on this call knows, we had a historic loss of honeybee colonies. And this was a severe loss, and it was sudden, where beekeepers who had kept their colonies outside during the winter suddenly lost their adult bee population, or beekeepers who went to inspect their bees to take them out of sheds, those overwintering climate-controlled sheds, suddenly realized that the majority of their colonies were dead. We take these losses very seriously. They create instability in our food system because growers rely upon reliable pollination, and it creates instability in our beekeeping industry. Most of these are small and medium-sized farms, and these severe losses equate to severe financial losses. I think everyone on here has heard that $600 million number. With the help of ABF and HPA and Project AFSM, they were able to put together a really helpful survey early on where we could start to describe to the public and policymakers what it meant to have these bee losses. And I believe that is one reason why the conversation this year has been so beekeeper centric and bee centric instead of going off in left field very quickly. Now, this is a schematic I put together, and I want to give everyone here an idea of how we respond to losses. Because there's no neon light suddenly saying you need to go out and sample for losses. The red person here is an indexed case. It is someone who calls in saying, we need help. In this particular case, it's just going to remain an unidentified person. But they called in saying, just starting to talk about their losses. And the way that we respond is actually, it was a vendor that called me saying, you really need to talk to one of my clients. And that was super helpful. The way we respond is we say, well, how about you call a bunch of your friends, don't email them, don't text, call them, and ask them to call me. You can give out my number freely today. Just go ahead and do it. And if they call me, I'll record their information. What ends up happening is we very quickly build an impacted network. So we start to get an idea of how broad are the losses, how severe are they, and some background information that might give us some idea of what actually is causing them. And within a day, we only had a trickle of information come in. So, I had gone home. I did my last interview in a parking lot, actually, outside a gas station on the way home. And I went home going, something's going on, but at this point with the information we have, we're not completely sure. We get more people coming in the next day from that first network group. We had a new person, and they gave us a lot of really good information that helped us understand how broad these losses were. Now, we still don't know at this point that they were going to be historic losses, but we understand, okay, it's not just a couple beekeepers, it's more. While this is going on, information already on the 21st has been passed up to different personnel, at the USDA and other agencies. And it's at that point, it's just kind of alerting, right? No one knows what's going on, just alerting. But there's a lot of other work right here. But by either the end of the 22nd or the beginning of the 23rd, Judy authorizes the field response. And I really need to give Judy a lot of credit here. She is an incredible leader. And before anyone knew the breadth of these losses and how impactful they were going to be, she just declares, just go and sample. And that's what a real leader does, right? Jay at the same time is looping in extension in several different states and bringing in more information. And Izzy Hill initiates the federal response. So the reason I'm sharing this is I want you to see in real time why we like intact working groups and how important they can be. Within essentially 36 hours, a federal response was initiated, and I'm trying to book my ticket after hours with our travel agency that we have to use. And by January 24th, I'm in the air going to California, and we have an all ARS, Agricultural Research Service, so a bunch of other labs getting involved, getting briefed, and Andrew flies out a couple days later. So this happens really quickly. This is Andrew Garavito. He flew out just after I flew out, and for over a week, we just collected bees. Andrew has left the USDA. He's an incredible researcher. He's like me, a younger researcher, got into bees, didn't have an academic background. He has great rapport with beekeepers. And is exactly the type of person that I want to be working with on an event like this. Him and I do the same thing. We make sandwiches the night before, we get a gallon of water. When we get to a bee yard the next morning, we never leave the bee yard. All we do is sample. When we get hungry, we drink water. When you finally get hungry, you eat a sandwich and you just keep working. So bathroom breaks are behind your pallets. and we stay in the yard. It's not great weather at the time of the year that we're doing this work. So we force ourselves to get as much done as we can before, so that's not too cold when we're getting into colonies. But eventually we just start opening colonies and we just work. This is an example of a dwindled colony, a typical one. This is an example of a typical surviving colony. The first thing that we do in the mornings, because it's a little too cold to get into these, is we just go through dead outs. We collect bee bread and wax from dead combs. And to prioritize and maximize sampling time of live colonies, in the hotel room, that's when we extract those combs, and we do that at night. So we get going in the morning, whatever time that is. We try not to have any errands. It just cuts down on how many samples we can collect. We get back, we'll usually do a dinner apart just so we can kind of have our own alone time. And then we just essentially listen or watch a movie while extracting bee bread. That's what I'm doing right here and what Andrew's doing. This in California is a typical dwindled colony. There's not enough bees to cover the worker brood anymore. The beekeepers did expect the majority of these to make what's called almond grade, meaning that there are enough bees in there to get paid by a contract. In this particular case, the majority of the colonies either died or dwindled. Now, this is a really big deal, and I'll go back just a couple pictures. This picture right here, this is a holding yard in California. There are an equal number of colonies behind me. I'm in the center of the yard, as there are in front of me. And there's all these extra colonies over on the side. We estimated there are about 2,000 colonies there. 90% of them are dead. The reason Andrew's opened up the cover the way he is, he's not using a smoker. He's just going around trying to find surviving colonies so we actually have something to sample. Getting out there and doing this work very quickly, we believe is critical so we can capture things before they disappear. Now, what do I mean by capture things before they disappear? I said our working group is pretty broad and we rely upon really good relationships with our beekeepers. This is an excellent example of what a good relationship with a beekeeper can mean. We asked them not to clean off pallet bottom boards and to leave dead colonies where they are. Now, they picked up the dead colonies they had to, they got to get their work done. But they left all of the bee material for us. When we sample what's living, we don't capture what died. That's one of the biggest problems with the work that we do. We want to capture bees as they're dying. We don't want to only capture what's surviving and miss what's disappeared. So I got really excited when we show up here and they left all of their fresh dead bees on the ground. Now, a lot of them decayed. We can't do much with them. But things that are fresh, dead, or dying, we can collect for both pathogen and pesticide analysis. And our methods are very clear. If we collect something for pathogens, we have to collect an equal amount for pesticide analysis. We don't want to have gaps in our sampling. In this particular case, I'm not necessarily interested in the bees on this board. They've already decayed a bit. I'm interested in what's amongst these bees. And this was the first real evidence that Andrew and I had that mites were going to play possibly an outsized role in this year's losses. When we start to go through these pallet bottom boards, there are hundreds of dead mites in the debris. And these are colonies that had passed away and died. And this is what we call a survivorship bias, where the surviving colonies don't have the culprit that caused the loss of the dead colony. And had the beekeepers just thrown this material away or not left it for us, then we wouldn't have had this observation. So this was extremely important. Now, we ended up collecting quite a few mites, and the first thing that we did was we wanted to sample them for amitraz-resistant genotypes. There's a collaborative lab in Baton Rouge. We sent those samples there. Frank Brankovich did it for us. And we unfortunately found that 100% of the mites had amitraz resistance in all 6 of the operations. Now, these operations are quite large, so they represent a lot of colonies in the country. We have more mites, and there was an internal discussion on what do we do with these mites. We can process them all for amitraz resistance, But once we do that, we can't do anything else with them. We're pretty limited. Like I can't do that extraction and then look for viruses in those mites later. So we ultimately decided to do what we thought would be an acceptable minimum. And we also had other information of unpublished reports supporting this. So that was really important for us early on. And it was part of this preprint that is currently under review and definitely got spread around. I think everyone in this group is familiar with it. So I showed some pictures of how we collect samples, what we're looking for, why we're doing what we're doing. I'm going to go into a little bit of the data from that preprint. So these are the bulk bees that we collect. I'm just going to go back because the picture is really good. Wow, it's too far back. Andrew right here, that's these bees. These are the surviving bees from the center of the colony that we're collecting to do this viral analysis right here. So these are 50 bees that have been crushed up, extracted, and then we did viral analysis on them. We did a screen for 9 viruses, plus nosema and plus trypanosomes. This is not nosema spore counts. This is detections of a transcript inside of the sample. And we didn't have any red flags here. Well, we didn't have any red flags in terms of statistically one virus showing up more in weak colonies versus strong colonies. So we have strong, medium, and weak colonies here. And of course, when we sample, we would love to just see a giant neon light saying this is the culprit. Because the quicker we can identify something, the more service we can provide to beekeepers. The alarming thing that we did see, however, was a really high prevalence of acute bee paralysis virus, where it showed up in 72% of the colonies we sampled. Now, I didn't do a random screening. We're purposely finding dwindled colonies, and we try to pair them with a control colony. So we don't think this would represent broadly colonies across the country, except for the fact that there was no significant difference in ABPV between the weak and the strong colonies. ABPV is very deadly. It kills your bees very quickly. It's why we normally don't see it at high prevalence in honeybee colonies. And I'm going to talk about how quickly it can kill your bees a little later with the video. So this was the first indication that we might have an ongoing infection, a viral infection in our honeybee colonies. The colonies that died, the colonies that were weak and affected had it. And we believed at that point it had spread or was continuing to transmit in the surviving colonies as well, the surviving strong colonies. The other thing that really stood out to us is what should be the most prevalent pathogen. DWV has become the most prevalent form of DWV in colonies across the country, showed up at very low levels. Now, imagine you're an expert in the field and you see this data. The first thing you should ask yourself, the first thing all of us ask ourselves is, did someone make a mistake? So we have a lot of people that work at BARC. Judy J and I are a nimble little group, but Don Boncristiani and Allison Shawless were techs who are experts at this, at doing this extractions, did this high throughput work real quick. We're also involved. We all looked at the data and said, did we make a mistake? And Don was already rerunning the DWV by the time we brought it up. It wasn't a mistake. But I'm using that kind of example right there to exemplify why having a lot of us in one spot is so helpful. I don't sit around with this information for a week wondering if something's wrong. You have a colleague looking over your shoulder, immediately going, rerun that. So at this point, we're not sure if we should really be looking for a pathogen at this point or pesticides. We keep our minds very open. In fact, at one point, I had a bunch of different things on Post-it notes for potential culprits. Some of them were one beekeepers write in, like some beekeepers thought it was tracheal mites coming back. We did screenings for that. We were looking for amitraz poisoning or nosema. We look for those things. We don't just ignore. But we got our first really big cues for when we did the analysis of the dying bees. I should have said the first thing we do when we get to a yard is we collect the dying bees. Once we open colonies, bees can fall and get cold, and we don't know if they were in a colony or dying. So the first thing we do is collect, and that can take up to 45 minutes. And it takes it that long because I collect enough for pesticide analysis. I need a few grams. Plus I collect enough for pathogen analysis. So we try not to disturb the ground at all, change gloves in between colonies. As you can see, I'm just laying on top of the pallet, just picking up bees dying on the ground. Sometimes they're coming out of the colonies. We had dying bees with pollen sacs full coming back into, well, they weren't coming back into the colonies. That'd be great. They were just landing in the yard and dying in front of us. So we make sure we collect enough for both. This is what they look like in the field. They're essentially immobilized. They can't move forward at all, or they'll be stuck in the grass with their tongues out. When I did individual bee extractions, and I did this work here, and then looked for viruses, we got a different story than our bulk bees. Suddenly we see deformed wing virus at high levels and high prevalence in the dying bees only, not the control bees. So the asymptomatic are my control, they're that light blue, my morbid are the red. And we also have a similar pattern of DWVA there. And that was the first real indication that this was a Varroa pathogen issue. We have that survivorship bias evidence of the mites in the bottom boards. And we have this pretty clear data with the DWVB in the dying bees, not the surviving bees. We think that's possibly why we didn't get a high prevalence in our bulk screenings, that essentially the bees died out from the colonies. Now, I also collect enough material for experiments. I'll take an individual bee in the laboratory and I'll crush it up and freeze thaw it a bunch of times. The virus are inside the cells, but when you crush them up and freeze thaw them, those cells lyse and the virus is released. And we make inoculum from them. I do this every year. So our lab is, this is what we do regularly, weekly, sometimes the year daily, not making the inoculums, using them. So this was no effort for us to suddenly do an experimental portion. And this filter over here essentially only lets viruses pass through it in all practical terms. So I made a bunch of inoculums from dying bees and some control bees from California. Injected them into pupa to see if they were infectious. And then we used Jay's handy dandy little setup right here to run some bioassays. And I'm going to show you the data from these assays. So all of these bees have been injected. We have a negative control that's not injected, and that tests the stress on the system. But everyone else has been injected either with heat inactivated virus. So we just heat up the virus so it's still there, but it's all broken up, or a live virus. And this is the data we have. If you saw that preprint, this is one of the figures. And let me just kind of describe it. So my y-axis is the survivorship probability. My x-axis, the length of time a bee survived. So that perfectly straight purple line, no one died. Everyone lived the whole time. As soon as the line goes down a little bit, that's a bee that's perished. If a line goes down a lot very quickly, a lot of bees perished. CV3 is a morbid pupa. CV4 is a morbid adult bee. CV5 is a morbid adult bee. And CV7 was a control bee. And we really want to look at a couple different stories that are being told here. I don't have the viruses up here. CV3 and CV4 predominantly Varroa destructor virus. The pattern that we see with Varroa destructor virus is that bees live for a period of time, they're fine, and then suddenly they die off. And in this case, it's a little more than 10 days after we started, after injection. CV5 is a different story. This one is acute bee paralysis virus. Essentially, we inject the bees, they suddenly die. And CV7 is control. So we looked at survivorship with that ABPV. And just because of the 10-minute warning, I'll spare you a little here. We had to take that individual bee and dilute it down to less than a billionth of a bee before it had no adverse effect. And that just bespeaks of how an insane amount of virus is replicating in some of these dying bees that we're procuring in these loss events. We calculated out, now this is theoretical, if you could pinprick and use up all of that inoculum, you would kill approximately all of the adult bees in 12 and a half tractor trailer loads of colonies. That's how much infectious material is in that single bee. And that's going to vary widely on your model, but that's just kind of like a simple way we could just try to describe how infectious it is. I'm gonna get rid of it. It's down here. So these are our control bees. About 16 hours after injected, they're just running around the petri dish. They're eating their fondant. They're wondering why they're in a little plastic container. These bees were injected with approximately 1/1500th of a dilution. This is the CD5, 15,000th. We're going to go over to the next one. So this is 16 hours later. This is 150,000th of a dilution. So some of them are still wriggling. And this is our 1.5 millionth dilution. So this is the point where we realized we had to dilute it a lot more. On all of these bees were dead 24 hours later. So the reason that we did this is it gives us strong epidemiological evidence if we can recreate symptoms from the laboratory in the field. We don't care what's killing bees, we just want to identify it. And our group identifies hazards. We're so mission driven that when we colloquially put it, we want to help keep food on American dinner plates. The reorganization plan is to move the BARC to 5 different federal facilities across the country, without the goal of keeping any working group together. As a professional, my qualm with this is for me to get any of the work that I have just presented done, I have to have a working group that I'm used to working with, and that is a large group allowing us to take on essentially national problems. Once we break up those working groups and fracture those working groups, our output additively isn't the same. It's all suppressed. It's much lower. And we're still waiting on the rest of the plans. As of right now, the timeline, who will be moved, who might be forced to retire, none of that is actually written out yet. So what I'm going to do is take 2 minutes right here, and there is a public comment period where whatever your opinion is, whether you're for the reorganization or against it, you have an opportunity to write in and voice your opinion. That QR code, just pick up your phone right now and shine it at that QR code. It will bring you to a Google Doc where you can click on a template and go to your email and send it, or you can just type in reorganization@usda.gov right here. We're highly encouraging people to write in on behalf of beekeepers.
Thanks for all that, Zach. I think that was really helpful. I was going to read some questions, and it looked like we had a couple of people, Helga and Blaine, essentially asking, why decentralization is not preferred, but you literally just talked about that at the end. So I don't think you need to go back into that unless you feel like you want to add more to that.
Yeah, I put this together really quickly, and it's also an emotional thing. So if that clear communication got lost, I apologize. As a larger working group, we have so much expertise in one unit that we're able to act very quickly and efficiently on big problems. If we break people up and we're all in our own little hub, then it becomes much more difficult for me to do my day-to-day tasks, let alone work on something that is affecting the nation's agriculture. I think think of any task where you need 2 or 3 people and essentially just break them apart. That would be the biggest reason. And by the way, I'm not fully opposed to those hubs. I would actually like to see them in addition to what we have. We have an extremely important industry that services agricultural crops. Unfortunately, we're going to have hardships going forward in the future that beekeepers are going to have to deal with. The amitraz resistance in mites is a big deal. The second biggest threat isn't here yet, being tropiololapse. But what we have are 2 acute hazards causing severe impacts on bees. I want to make sure that our working groups are intact so we can actually handle those national problems.
Yeah, I think you did a good job in explaining, or giving examples of the science and of the projects that you've been working on, and the kind of collaboration and coordination that is like fast, efficient, and you wouldn't be able to get that, if things were just chopped up and dispersed in different areas. So I think you did a good job in setting the stage for that. Um, Somebody asks, how many of the hives had resistance to amitraz, but you had said it was 100%, and somebody also answered 100%. So I think that's right. I think it's referring to the mass die-offs.
Yeah, and I think they're specifically asking for the number of colonies. My memory is good, but it's not that good. I'd have to go into the supplementary on that preprint and look at how many colonies that was sampled from, because off my memory, I don't know. I think they're
Um,
asking colonies, not necessarily how many.
oh, okay, gotcha. Yeah,
Yeah.
okay.
It should be in the supplementary in that preprint. They can pull it right up.
And then was there any nutrition related evidence looked at? Mandibular gland, hypopharyngeal gland?
We haven't done pathophysiology yet or dissections on the bees. We have extra samples, so if someone wants to do that, well, I will say on nutrition is we sent bee bred aliquots to Mississippi, and Pierre Lau and Arthi are doing analysis on that, both the type of pollens that are in that bee bread, and then also the heavy metals that might be in that bee bread. This now brings up a really good point. We have multiple bee labs across the country, and not only do we work really well with ourselves within, the Beltsville bee lab, but we also collaborate across. So it's being pursued. We don't know yet.
Okay. And Beyond Honey Apiaries gave a nice story about their experience going to the lab. It sounds like, it's just a great, not only do you do good research projects and work on good stuff, but it's also a very welcoming, sort of open place to go for anybody who wants to take a look at what's happening down there. That's nice. Zac, based on this example that you illustrated, how fast were you able to act on this mass loss if the lab is broken up? What would have changed in this scenario? How much longer would it have taken to find the problem?
If Andrew didn't come out, we would not have the results that we have now, right? I rely upon his expertise. He relies upon me. It's how we catch ourselves from making mistakes. We're able to go through a lot more colonies. Just one person, I go out there, I sample, a few operations over a longer period of time. We probably miss what needs to get done. A practical example is I'll be driving to one beekeeper and Andrew will be on the phone just calling one beekeeper and after another, trying to organize when we can meet the next beekeeper for the next day, right? Like there's a lot of hands that go involved in this. We have support from our lab back home. Once we get home, I can sort samples knowing that two people are going to wholly focus on doing extractions from one set of samples. I know that Judy is going to do work that I don't have to do so that I can focus on just my task. Essentially, the response doesn't happen, is the quick way to put it. In fact, even with Florida, even though I was the only person down there sampling, there was so much support from the home lab. And once I got there with, one person figuring out who was going to process the samples for pesticides, who was going to do the extractions so that we can push that through pretty quickly. That's just a large team. So essentially, you just don't get the same result. I'm starting a new lab at UMBC, and I want to incorporate the diagnostic services. And part of the question is, who do we serve? I was shooting for anyone within a 2.5 hour radius of the lab. And I think the reality is it needs to be a far smaller pocket than that. I have to have a full-time lab manager, myself, and active funding coming in just to do 2.5 hours and reliably get services back to beekeepers.
Somebody's asking, to whom should we direct our letters for maximum impact?
I don't know. The reorganization email is what we have for the public comment period, and I think that is the way to maximize your impact and kind of encourage you to take that route.
And someone submitted a sample for testing recently. Do you think the decentralization will affect the timeline of that submission, or?
So we don't have a timeline of when BARC is going to be closed or when we're going to be moved out right now. So as of now, we're just continuing operations as normal. In the case, it's the disease diagnostic lab. Sam is collecting samples and he's processing them. There's a surprising number of things that can interrupt services, but as of right now, the reorganization, if you sent a sample in, shouldn't impact that.
Helga says the model probably needs to be what we in medicine learned at the NIH. Intramural can be very useful, but extramural has advantages as well.
Oh, I think this person put it really well. The Beltsville lab seems to be more the sum of the parts, break it up, and you're less than the sum of the parts. That's a great way to put it.
Is there a plan to decentralize the other B labs as well? But I guess it sounds like there's other smaller B labs across the country that are probably not part of a hub like this one, right?
Yeah, you've got a few different labs. So Stoneville, Mississippi, you either have 2 or 3 SYs there. Arthur and Pierre Lau are kind of the most famous out of there. At UC Davis, you have Vincent and Julia. Baton Rouge is the other largest lab. Michael Simone Finstrom's down there and Frank is down there. Liz Walsh, who we all love, is down there. I know I'm missing names there and get mad. I'm sorry. And then we also have the Native Bee Lab that does honeybee research as well in the ARS system out in Utah, in Logan, Utah. What am I missing? I think the problem that gets confusing for the public and some beekeepers is we have a bunch of different organizations and we start talking about them as if everyone is fully familiar with them. So we have university systems and state systems. Within the federal system, we have different agencies. Under USDA, we have this thing called ARS. The Agricultural Research Service has a bunch of bee labs.
There's a couple of references to the private sector, and I have to say, when you can't compare private sector to government in general. I mean, the private sector, they're out for profit, capitalism, and I do think that the goal and the science could get lost if this kind of stuff is privatized, because they're worried about the bottom line. They're not necessarily worried about outcomes. They're more worried about the bottom line, I would say. But somebody is asking, please address why the private sector can or cannot perform the same functions as BARC. Are there examples where privatization or decentralization has had poor outcomes?
You know what? I'm going to be talking outside my expertise there because now you're getting into, yeah, it's not my expertise answering that question. We know that because we're contracted with like biotech sometimes, that there's research that they want us to do, but we're much better at carrying out that they're not. But to answer that question broadly, I can't do it justice. So I don't want to like punt or deflect. I just kind of openly want to state I'm not the domain expert on that one.
Why were the pesticide samples not sent to the Gastonia lab?
Oh, that's a great question. So we early on had Project AFSM connect us with Scott, who was willing to bump us so we could get our samples done right away. That was the number one reason. The second was a private donor came in to fund it. Sometimes we'll collect samples and we have to find it within the budget to process them. So this can be done through like an interagency or an inter-lab transfer. If one lab has extra funds, we can transfer over here and get them processed. That all takes time. And when responding to severe loss, we're not going to wait on time. So we connected with Scott, and one of the things so right away, beekeepers are telling me which insecticides they're worried about, for lack of better words. So we confer with Scott, can you detect all of these? What are your limited detections on all of these? And ultimately, with that decision, it was they can do them right away. Donor's going to cover it. And your limited detections are really low for the compounds that we're very interested in. So you put that all together and it's a recipe to say yes.
And Kyra Wagner wants to know, do you think universities can or should pick up some of the bee sample analysis and diagnostics using a fee for service model? It's an interesting question.
Yeah, it's a really interesting question, Kyra. I don't know, because other labs, for example, when they'll do like a pesticide screening, they'll charge $200 for that screening. The problem I have with that is you are charging an amount that's equal to the value of the underlying asset that you're doing diagnostic services on. So it disenfranchises beekeepers from seeking those services. On top of that, a lot of beekeepers right now have this response that if it's viruses, there's nothing I can do anyway, so why should I pay for the service? And I don't think that's the best perspective, but it's totally a fair perspective. So I don't think unless if universities can bring that number all the way down to cost, not including labor, essentially cost of reagents, that are going to be able to do that. We're able to pick up that that bill partly just because of how we're funded, right? I don't have the best answer to all of that, but that's my biggest pushback on universities doing it. We really would like universities to be able to pick up more. I would argue one reason that my lab is going to do this is over the last 2 years, I've been assisting beekeepers. They'd send in samples and I'd do some of the molecular work. They're modernizing the diagnostic lab to do the molecular work. And I always ask beekeepers, so how many colonies do you have? How many colonies are at risk? How many colonies have you lost? And it allows me to do a very rough economic harm assessment. But then when we do the viral screening, you start to see which viruses are linked to that economic harm. I would argue universities should be doing this because it really improves their ability to do grant writing. It's very easy to now say we should investigate this because of, this information that we put together as a pattern amongst a bunch of beekeepers. One of the things that becomes really difficult for us is influencers, people that want to post online. They can put out so much more information than we can, much quicker than us. So sometimes we're trying to catch up with our science, and something else has always already caught a hold. And we see some of this popping up in the Q&A in the chat, and some of it's totally fine. One person brings up a virus that was never detected, or someone brings up no amitraz resistance found in one study. For the most part, I'd much rather just kind of keep my head down, process samples, and then put out good information for beekeepers. But it's getting difficult in this environment to do so. And I think with AI adding to the speed at which people think they can have access to good information, and how information can spread super quickly, it's going to get more and more difficult for us. Our industry definitely has some hardships that we need to navigate going into the future, and potentially some of the biggest ones haven't arrived here yet. So we, as a small industry, I think have to figure that part out. I definitely don't have the answer. I always tell people I'd be much richer if I had that answer. Private sector does pay well. I was looking for jobs at Amazon. I got to admit this spring. I really was. It was getting so stressful over here. Yeah, Terry Kane brings up a really good point. It's prohibitively expensive. Terry, we have this problem where if we respond to a beekeeper and collect samples, it's really poor for that beekeeper if we don't process the samples. It's also just really expensive for us to process a lot of samples. So what do we do sometimes? And for a while, because when some of it was falling on me, it's not my job. I don't mean that like it's not my job type of way. It's just like I'm trying to figure out this niche so we can give service to beekeepers. We had this idea that we do pathogens first because it's roughly $22 a sample. And if we had red flags in the pathogens, we would pause there. And then Andrew and I were talking about it, and we're like, well, that's kind of a crappy model. You could have two hazards and then just have a big gap in knowledge on one of them because you stopped when you saw the first one. And that conversation really influenced how we sampled out in California this year, where we're very aware that we could have multiple acute hazards impacting bees. And we don't want to stop when we just have one. But then comes the cost, right? You have the personnel, you have few people with a lot of expertise to carry this work out cleanly and efficiently. And it's prohibitively expensive. So how do we navigate that? And I don't have that answer at all. But it's definitely a problem that we'll be talking for over the course of this year and probably at all the conferences. Is how do we address these needs? I want to thank everyone for coming on tonight. I mean, this was last minute. Sorry it was a little choppy. I do hope that you made your voice heard. And if you have any other comments to give me or questions why we want BARC to stay intact, feel free to reach out to me. It's pretty easy to find my contact information online. Oh, the last thing, I didn't say why BARC should stay intact. We're developing way too much farmland in this country, and we're getting rid of a lot of green spaces. This is a 6,500 acre green space just outside of DC and just outside of Baltimore that I'd like to see stay intact. You know, I have a vested interest. I come from New Hampshire, and so much of my state has grown up into housing. And it's night and day difference between Vermont right next door. And I really don't want to see BARC go the way of essentially what New Hampshire did.
Yeah.
And we've had pressure for years. So,
I'd like to thank you, Zach, for sharing your experiences, being part of that lab and what it means to be in that lab and the impact that lab is having, and making us aware of that and giving us an opportunity to publicly comment on whatever our opinions are on moving this policy forward. So I really thank you a lot, and the Women's Bee Group from the CCBA, and putting this on tonight, and everyone who showed up and who gave an hour, a little bit more of an hour of their time to be with us tonight. So thank you all for sure.
George.